didn't go through it, but Sarah did. We know that if log base b of 1 equals 0, it makes sense, right? B to the what power equals 0. If you would have done b to the what power equal, b to the what power equal 1, 0, right? So b to the 0 equal 1. And then ABs are your example. We talk about this. We talk about this and this. So those four you need to know. In mathematics, I don't recommend you memorize it. I don't. If you ask me, I'm not gonna list. I won't be able to list it all for you. But I understand it, right? As long as you understand it, you never forget. So those are four basic log rules. Let me introduce you another one. Start out like this. Again, this part is I'm explaining. The formula is the one that you need to memorize or understand, right? Write its equation in exponential form. If it bother you, you can put the log on the left. I like it on the left. Like that. And then remember that tornado arrow, right? To transform from log to exponential. So now I have b to the x equal m. And the second one will be b to the y equal n. So far, so good? No. What? Maybe you guys talk less and listen more. You should keep up better. Now I can multiply two of them together. Right? When I meant that, I'm gonna multiply this equation with this equation side by side, right? So m times n equal, multiply the left-hand side together, b to the x times b to the y. M times n is nothing I can do. But b to the x, b to the y, how do I combine them? You should be able to know. Add, very good, right? Add, right? So those rules you should remember, right? So what I'm going to do is I'm going to add them together. So m times n, rewrite the left-hand side. On the right-hand side, the exponents add. And then write log form. That means they want you to take log base b both sides. I'll tell you why we should take log base b, but not log base a or base c or base d. It has to be log base b. So log base b of the left-hand side, and then log base b of the right-hand side. By the way, these you don't have to know how to derive this, okay? It's not gonna be on your test. But you should understand this as well. If you look at rule number 3, I just boxed it earlier. If I have log base b of b to the x, I can cancel this and this, right? Due to inverse property, right? So here's same thing. I have log base b and b here, and the b for the exponential function. They cancel, so x plus y drop down. Right? And on the left-hand side, we write it as log base b of m times n. So that's why we take log base b, right? So they can cancel. Now, I'm going to substitute what is x and what is y. Remember in the beginning, what is x and what is y? X is log base b of m, right? I'm going to replace x with log base b of m. That's what they say, substitute x and y with log base b of m. So continue down here, log base b of m. And then replace y with log base b of n, because that's what the original condition is. Plus log base b of n. Bring down the left-hand side. There's your new rule. Right? Log of the products becomes sum of the logs. So we write, so describe product rule in word, we say log of product equals sum of logs. You don't even have to write these down. I just explain it to you. All I want you to understand it. I'm not going to ask you to re-explain it on the exam. Right? So it's called the product rules. Maybe I should let me I'll highlight the whole thing. How come it won't make a nice rectangle? Too long, I guess. There you go. Have its own mind. There you go. All right, so right there, log of m times n equal log m plus log n. This is what I don't want to see. And have a student do this. Log of m plus n is equal to log of n plus log of n. They distribute it, which is wrong. Right? We don't have any rules say that log of n plus n is equal to that. We have the product. Well, if it multiplies, then we can make it like that, right? So be careful. Don't try. I know it's tempted, but don't do that. Okay. It's kind of like, don't write this down. It's kind of like square root of n plus n. A lot of people just love to just break them apart, which is wrong, right? Which is not right. So same thing with log, right? We don't do that. For the second one, it's the same thing. It's pretty much the same thing. You don't have to write this down. It's the same thing. Now instead of multiply, I divide. So m divided by n, and then b to the x divided by b to the y. When you divide, what do you do with the exponents? Subtract, right? Remember, you only be able to use those rules if the base are the same, right? Like 3 to the x divided by 3 to the y. Right? So you subtract. But if say I have 3 to the x on the top, 2 to the y on the bottom, we don't do that. So here is equal to b to the y, b to the x, subtract y. Rewrite the left-hand side, and then take log both sides. Again, log base b, because we need to cancel. B to the x minus y. It's the same process, really. It's pretty much the same. It just slightly change it slightly a bit. Usually in the other class, I asked students to write this higher class, not this class. Rewrite the left-hand side all the way, right? So log base b of n divided by n equal x minus y. Now, same step, you replace x with log base b of m. Replace y with log base b of n. So what do you see? When you have a quotient, log of a quotient, it becomes the difference of logs. So I write log of quotient equals difference of log plurals logs. If you notice that the log, the letter on the top, say letter M here, it's on the top, so it's carry a positive positive sign. The letter in the numerator, it carries the negative log. So that we have rule number 6. So for the basic rule, adding 2 more rules, we have 6 rules so far. I'm gonna have a hard time doing. It's just too long, it won't listen. Those are not given on the exam, so you should, if you don't understand it, at least memorize it, okay? And again, those part up here, if you want to forget it if you want. Not gonna be on the exam. But I would love you to understand it. Apply, so these may more like your exam problem. Apply. Expand each expression and simplify if possible. So here I have log base 3. Remember, log of products becomes sum of log, right? So log base b of 8 times x becomes log base 3 of 8 plus log base 3 of x. Am I done here? Well, what can I simplify with? I think I was thinking, I think I know what you're thinking. I hope I know what you're thinking, but I don't think this K will be applied. Here we done. Here this problem we done. But I'll tell you what might be a mistake when students take the exam. So I say, oh, 8 I can rewrite as 2Q, and CIC number 3 I cancel. What has to be matched to be canceled? The base, right? The base, not the exponent, right? So the 2 is supposed to be a 3, so you can cancel. I'm telling you this because students tell me that when they at home, they do the homework, they understand what they're doing, but for some reason on the exam, it's just not the same. And it's true because exam, you're not allowed to look at the book or notes, right? You have a time set, you have pressures, right? So it's a different story. My advice that for those of you who have problem like that, maybe the first 2 times, look at the notes when you do the review, but the last time, do it without the notes. Do it without taking a look at the notes. Even better, time yourself. So it's a 2 different things. Right? Knowing it and be able to represent in your own writing, it's 2 different things. This one, how many factors do you see here? Factors. When I say factor, it means something multiplied by something multiplied by something. How many factors? 3. 3x and then y plus 4. So I see 3 factors. 1, 2, 3. So that means I'm going to have 3 logs. So they all multiply. So logs base 3 of 3 plus logs base 3 of x plus logs base 3 of y plus 4. The last 2, nothing I can do, right? The letter and the number. And again, do not distribute the log, okay? It's tempted, but it's not true. Okay? Those are part of your log. what I meant by part of your log mean when I say square root of, don't write this down. When I say square root of x, when I write a radical expression, I have to have a radical and a radicand, right? I don't ever write like that, right? I don't believe it like that, right? It's kind of like writing log without no input. So those are part of the input. Am I done here? Very good, right? You can cancel, right? Cancel it. So log base 3 and 3 cancel. So we have 1. And then we write the last two. Very good. Now we're done. Number 4A, is the quotient. So quotient becomes subtraction, right? So logs base ln e minus ln x. And I recommend you have it on top of your mind at all times, right? No ln e equal 1 and e to the ln equal 1. Those two things you see all the time, not just math class, statistics class. The reason being because ln is the same thing in log base e. Right? It's canceled with the e. So 1 minus ln x, and now we're done. Oops. 4b, that's you try 1. Number 5. Oh, do you have any question? I'm sorry, I keep going without asking. So far, so good. Number 5 is a little bit more involved. What should I use first? What rule do I use first? Quotient, right? So we combine them to one. Very good, thank you both. So this is equal to logs, it's log by 10, so we're not gonna write the base, of x over z plus x divided by y over z plus y. Again, I'm just telling you the mistake that I see over the year that I'm teaching. I see people do this. And it all come down to, you know, you're not study good enough, right? And I'm not blaming you or anything. I know you guys have other classes. I was a student once. I had the same problem. This is what I see, right? Exam, you panic, you forgot, like, oh, this is what, maybe this is a quotient rule, right? When I ask you to combine, you only have one log, right? So that's wrong. Now, right now, as your level, we don't like complex fraction. What complex fraction mean? It means you have a little fraction over another fraction. So we need to simplify this. This is what I'm going to do. There's many ways to do this. You do it your own way, but I'll show you what I do. For that part right there, the one I highlight in blue, let me rewrite this. Just rewrite the part. I need to get rid of the z. So what is the LCD here? All four fractions. What the LCD? Oh, sorry, my handwriting here. So I'm gonna multiply the top by z, maybe z over 1. I like to put it in terms of z over 1, and the bottom by z over 1. Am I changing anything? No, right? I didn't change anything. I don't change my expression. Now I'm going to distribute. So the first one, the z cancel, it's just x, and then plus xz. That's the top. And then the bottom is gonna be y, z cancel, and then yz. That's it. You can factor out the x if you like, but it's not gonna make any difference. We can leave it like that. So log of x plus xz divided by y plus yz. Remember, your goal is to combine into a single log. I want it to be one log at the end. Okay, so we're done. If you cannot cancel anymore, we're done. Why don't you guys try number 6? I'll give you like a few seconds to try number 6. Write it down because I'm going to change my window. I post my note right after class. I try to be, so you have it on your workshop. Yes. After, I believe. I don't remember. I think after, right? After, yeah. I won't be here though. I'll be out of town. I'll email you guys about that. I'm not writing the exam this time. So as soon as Tom have the exam set up, I'll let you know what to focus. Okay. Four 4.5. What you got for the answer? Anyone, what you got for the answer? Okay, very good. 3. So this is product, right? So log basics, and then you multiply all of them together, right? 2 times 3 times 4 times 9. Log basics. Here, what I do, I see basics. I want to cancel the basics, so this is what I do. I see. Well, you're gonna take a few. You have. I'm just gonna write it down. Yeah. But back in the day, I'm not allowed to use calculator, so it's a different story. But there you go, 216, and then if you take in your put in your calculator, what 6 to the what power give you 216? 6 to the third, right? Very good. That cancel is 3. Now back then, I don't have a calculator. We have a log book. We actually look up the log. I don't know about you know about that. You guys so young now. So this is what I do. We have a lot of trick back then because we don't have technology. So log basics 2, 3, 4, 9. I'm gonna write it at, so 2 times 3 is 6, right? The 4 I'm gonna split it into 2 times 2. The 9 is gonna split it into 3 times 3. So 6, another 6, another 6. So I have 3 6. Right? So how I did it back then, but now you guys have calculators. Anybody done number 7 yet? This one we have to apply two rules at the same time. So log base 6 of 2, I can multiply the 2 with the 3, right? Could they sum? And then subtract. I'm going to factor out the -1 for the second group. I'm talking about the 2 guys. So it becomes log base 6 of 4 plus log base 6 of 9. What's log base 6 of 6 equal? 1. Very good. 1 minus. Now I can multiply them together. 4 times 9 is 36, right? Or 6 squared. Oh, sorry. It does that. And it doesn't save. I have to rewrite this. Log base 6 of 2 times 3, 6 of 9. Log base 6 of 6. We agree that's 1. Minus log base 6 of 4 times 9 is 36, which is 6 squared. Cancel again. And save that before it go up on me. 1 minus 2 is -1. Let me show you how it look on decimals. Right there. Froze. Right. 3 and -1. All right, so that's 6 rules so far. There's more coming. I'm sorry. Let me shoot the messenger. Another one is called the power rule of law. I call this the parachute rule. I'll tell you why I call it the parachute rule. Let me ask you, don't write this down. I can write x cubed as x plus x, I'm sorry, x times x times x, yes? Like that, right? Because x to the first times x to the first times x to the first, you add those 3 together, you got x cubed. Now, x plus x equal 3x. Right, so that's 2 different things. All right, so I just want to recall that. Let's construct the power rule of log. See what happened. Write in exponential form. So here is, I have what is my base here? Yeah, B. How come I have a different exponential? I think I didn't follow. Oh, okay. I got it. All right, so B to the what power? X, right? Remember log equal exponents, right? Equal M. I write backward. Usually I don't. In this case, I do because we constructing stuff. And then step 2 say raise both sides to the power of P like this. So far, so good. Something. Oh, okay, I see. Apply the exponents properties, a to the m to the n equal a to the n times n. So here we have the left-hand side, rewrite it. The right-hand side is x times p, right? And then write equation in log form. So I'm going to take log base b both sides. Log base p. I'm sorry, log baby. I'm sorry, log baby. Now you can cancel that with that. Right? On the left-hand side, I can rewrite like this. So LS on the left-hand side, LHS is left-hand side. Log baby of m. M to the p is the same thing as what? M times m times m times m, or how many times? P times, right? You agree? Yeah, it's kind of like x times x times x 3 times, so x cubed, right? M times m times m times m, p times, so m to the p. So far, so good? Are we good here? All right, are we good? I can apply the, what can I apply? So you know, one of the rules. If you have log of products, you can rewrite it as log of sum of logs, right? So this is equal to logs baby of m plus log baby of m plus all the way to log base b of m. How many times? P times again. Right, P times. So I can rewrite this as P times log baby of m. Have 1 plus 1 plus 1 plus 1 3 times is equal, 3 times 1 is 3, right? Log m plus log m plus log m plus log m p times. So the same thing, p times log m. Remember what it is equal to what? It is equal to this. This is what I start out. I'm gonna bring it down. So log baby of m to the p is actually equal to that. So what I did was I bring the p to the front. Long story short, that's it. Right? That's why I call the parachute rule. If you have a power in the argument, you can bring it to the front and multiply to the log. That's rule number 7. It's called power rule. Let's do this. Now that we derive that, we can do this. 8, pretty easy, right? All you have to do is bring the 3 down and times log base 2 of x, and we're done. Any suggestion for B? What is the power of x? 1/2, right? So I will rewrite it one more time. So I will transform it into rational exponent. So ln of x to the 1/2. Bring the 1/2 to the front. Multiply to the ln of x. What is the exponents for C? Yeah, 2x minus 1, right? That's the whole thing right there. So 2x minus 1, I would have put it in parentheses. Right? Multiply to my ln of 5. If you want to distribute, you can. What I meant by, you can take ln of 5 times 2x, subtract ln of 5 times 1, right? But I'm not going to do that. It's not important. Practicing the rule. Number 9. Number 9, we're going to simplify the expression using all the rules that we've been studying. What rule you should use first? I would, now, for me, my best bet, because they all ln, they all log base e. If I would have combined the two into one log to see if I can cancel the little guy, the 5, the 4, the 3, right? So what I'm going to do is, first thing, I'm going to move the power 2 to the 3, right? So by the way, there's more than one way to do this. So this one, I'm going to bring it back using power rule. So ln 4 plus ln 5 minus ln 3 to the second, which is ln 9. Right? Can I multiply the first two log using product rule? So ln of 4 times 5 is 20. Maybe I'll write out 4 times 5. So when you go home, look at my notes, say, well, where's 20 come from? Minus ln of 9. So ln of 20 minus ln of 9. Now I can use quotient, right? Thank you. So ln of 20 divided by 9. And let me give you the happy ending. If you plug in your calculator, you have log base e. You're going to have 0.051. They want it to 3 decimal places. Everybody know how to use it in your calculator? If you don't, you can look it up on YouTube. Oops. Any suggestion on IB? Oh, actually, that's you try to. I don't want to spoil your fun here. It should be easy. Oh, I'm sorry. You try to is 10B. So I look at the wrong one. Let me move it down here. 10B. Again, I'll post my note right after the class done. So you see it right away. Let's do 9B. I have a feeling it's going to be the same. ln 4 plus ln 5 on the top. Nothing I can do. Because it's quotient. Ooh, no, it's not quotient. Is it? Is it? Is this the same thing as this? Let me ask you. Let me ask you this. Is this the same thing as this? Is this? No. No. What I told you. ln of x over y equal ln x minus ln y. ln x divided by ln y, it is not equal to ln x minus ln y, right? We don't have those rules. So no, it's not. It's not. I know it looks like it's tricky, right? But it's not. We break them apart, right? We break them apart first. This one is, let's see. I can combine the top. Look, ln of 4 plus ln of 5 is ln 20. Rewrite the bottom. Maybe the bottom, I'm gonna move the 2 to the top, so become ln of 9. Or maybe you're right. Oh no, you're wrong. No, yeah, I was right. Yeah, I still keep my explanation. Yes. You will be able to do the quotient rule, but not until last minute, right? Now become quotient, right? Now become ln of 20 divided by 9. Ln of, you're right, the same thing. But somehow I don't like to do it that way. No, yes, it's the same thing. You're right, you're right, you're right. It's the same thing. It's the same thing. You're right. I was thinking of ln of x. Yeah, I was, no, so sorry. I was thinking it differently. Sorry. But my explanation was right, right? We don't have those rules. The same problem. Is this. Don't write this down. Don't write this down. It's this. That's become ln of, so ln of 4 plus ln of 5. I feel nervous when I subtract. X over ln y, ln x minus y. The reason I don't like it because there's a plus between the ln, right? That's why I have a, yeah, here I only have one ln, but here I have two of them, and then the plus in between. Let's just do that way. We use the rule. Just use the product rule first, and once you have one log on the top, one log on the bottom, you can apply the quotient rule, right? Because I don't have two different log of quotient rules, so that's why I'm nervous. It's kind of like, my analogous would be like this. 4 divided by 16, and then student do this. And it's still equal to the right answer, but it's wrong process. That's what I meant. Yeah, that's what I meant. All right, continue, 10A. Use property of logs to condense each expression, meaning you combine to one mother log. That's what I meant. What I'm going to do is I'm going to move all the exponents, all the quotient, I'm sorry, all the coefficient of log becomes the exponents, right? So power rules. So this is logs base, or log base 10. So log of 4 squared plus log y plus log x minus log 2 cube minus log to the 1/2. Can I rewrite it as log to the square root of z? I can combine the first three, right? Using product rule. 4 squared is 16. Right? 16 times y times x. Sorry, my x should be up here. It look like it's in the base. Now, for the last two, I'm going to factor out the negative one like I did earlier. That means I have to change the side, right? Now I can combine those two using product rule. Minus log 2 cube is 8, so 8 root z. Now we apply the quotient, so 16xy, y-axis is the same thing as xy, over 8 root z. Number 12. Do you have any question? Please ask. It's a good time to ask now. Number 12. Number 11. Is this, you don't have to know it yet? We will do it real quick here. So I'm going to move the 2 to the 3, right? So first thing I see, I want to combine. Well, first thing I see, I want to combine the two logs using quotient because I see negative. But before I do that, the coefficient of log has to be 1. Right? So every log has to be clean in order to combine. So it's going to be log by 2 of 3 cubed, which is 9. Rewrite the first one. So minus log by 2 of 9 equal 1. Now I can use the quotient rule. So log by 2 of x minus 5 over 9 equal 1. You can remember the tornado arrow. 2 to the 1 equal the argument. 2 to the 1 equal x minus 5 over 9. 2 to the first 2. You can crisscross multiply, or you can do LCD, doesn't matter. So this is 18 equal x minus 5, x equal 23. And you can check this, right? You can check. Log by 2 of 23 minus 5 minus log by 2 of 9 is indeed equal to 1. What's your left-hand side? 23 minus 5 is 18. Log by 2 of 18 minus log by 2 of 9. Quotient rule. I can combine the log 18 and log 9 into 1 using quotient rule. So log by 2 of 18 divided by 9. 18 divided by 9 is 2. So log by 2 of 2 is 1, right? It's 2 to the first, right? We don't write it. Not 0. Careful, right? Not 0. So yes, it's equal. Yes. So that's how you check. For the log, yes. Yes. For log equation, yes, you must check because sometimes you have extraneous solution. Remember, what is the domain of log? From 0 to infinity, right? They don't take negative numbers. So you have negative solution. Now, negative solution doesn't mean it always checked out, right? You're gonna plug it in. If you have a negative argument, then they don't like that. We'll talk about that later. Don't worry, I'll talk about that later. That's tomorrow on Wednesday. Right, number 12, use the property of log to expand its expression. Assume all variables are positive. The same thing I said, log only take positive number. That's why they say, they have that sentence say, assume all variables are positive. If they don't say that, you have to put the absolute value around the variable. But don't worry about that now. Maybe you should worry about on the calculus if you're taking it. What rule should I use? There's many ways to do this. Product. So logs by 4 of 4 squared plus logs by 4 of x squared. Logs by 4 and 4 cancel. It's just 2. And then I can bring down the 2 to the front, yeah, using power rule. I'm done. C is your U try 3. Any suggestion for B? Well, the first thing I see, I'm gonna bring down the 2, right? Pair shoot. So 2 times log base 4 of x plus 4. Am I done here or should I expand more? I'm done, right? I know that it's very tempted to distribute the log, but no, we don't have that rule. So we're done. Very good, we're done. D, what I'm going to do first is I'm going to put the 5 to the front and then multiply to the whole log. So 5 times log base 4 of x squared times y cubed. When you some people are really good at this, they can do like multiple steps in one line, which is fine. Just and then I expand because its product now becomes sum of logs. Let me ask you, is this right? Is this right? Yeah, what I'm missing? A 5, right? The 5 applies to both of them, not just one, right? So you're gonna distribute the 5 to this one too. If you don't have to put the parenthesis around it. What else I can do next? Remember, I gotta explain it as much as I can. Bring down the power, right? So 2 times 5 is 10. Logs base 4 of x. And then 3 times 5 is 15. Log base 4 of y. Now I'm done. E. Ooh, E. You know, first thing first, I'm going to do quotient rule. And then with one thing at a time, don't think too much. So log base 3 of cube root of x squared minus log base 3 of 27 y to the 4. Cube root of x squared, if you rewrite it in rational exponent, would be what? X to the what power? 2 over 3, right? 2 over 3. So this right here is the same thing as x of 2 over 3. Remember the little, I don't think I say it. The boot method, right? You kick that 3 over, go under the 2, so 2 over 3. So this is log base 3 of x. I'm gonna go ahead. Can I move the 2/3 to the front and multiply to the log right away? And then for the last one, I can expand it. Right? So log base 3 of 27. The minus apply to both, right? I know it's plus log base 3 of y to the 4 like that. But now I'm going to distribute the negative. Rewrite the first one. There's nothing I can do. Log base 27, I can rewrite it as 3 cubed minus log base 3. Can I bring the 4 to the front as well? Yeah. And then 3 log, so that's just 3 here. Right. You want to rewrite to make it neater, you can. This one, try at home. I recommend you should. Please do try at home. I'll give you the answer, of course, but please try at home. All right, change your base. I'm not gonna go through this. Give me 1 second, just 1 minute. I just asked for you 1 minute. I'm not gonna go through all that again. I'll post it, of course, but I'm not gonna go through all that. Here's your change of base. I know that your calculator don't have anything other than log base 10 or E. There's a way around it. If I give you log base of x, I can rewrite it as either log x divided by log b or ln x divided by ln b. Let me demonstrate it for you. Just one, and then I'll let you go. I'll let you go. Log base 3 of 42 is the same thing as using the rule. I'm going to be log 42 divided by log 3. And then you punch in your calculator, it will be equal to 3.402. And this one real quick, and I'll let you go. Log base 2 of 3. I can rewrite it as log 3 divided by log 2 times log 4 divided by log 3 times log 5 divided by log 4. Look what I cancel. I can cancel that one with that one. Right? I can cancel that one with that one. So equal log 5 over log 2, which is the same thing in log base 2 of 5. Actually, no, don't write like that. Maybe you can punch your calculator because base 10s now, which is a good thing. I'm done. And now post it on Moodle right now.